Hello all. Welcome to Vizuara AI Lab presents Machine Learning in Production lecture series. We are on lecture 2 and our topic would be your data science could use some engineering. Let us see what we are gonna cover in this. We'll cover difference between data scientist and machine learning engineer. Many a times people are confused that what exactly are the roles of data scientist and machine learning engineer. They don't have a similar responsibilities and we'll check that what are the core differences between them. Next, we'll focus on the simplicity in all project work to reduce risk. We'll see how simple approach for the complex project can reduce the risk and complexity of big projects. Then we'll see about Agile fundamentals to ML project work. Agile fundamentals you might have heard with respect to software project management. But when it comes to machine learning engineering, you probably may not have heard them, but we'll see how agile principles are aligned enough with the machine learning engineering. Then we'll see the differences and similarities between DevOps and MLOps. DevOps and MLOps are very trending topics, but people often mix them and understand they are the same thing or same professions. But there is slight difference between DevOps and MLOps. Probably with the name you might say that okay, if machine learning is there in DevOps, then it's MLOps. But we'll see how this is little different. Before going to these topics, let us see. In last chapter, we looked at ML engineering through the lens of project. We have seen what are the core tenets of the project. And if you have missed the video, you can watch that video and then come to this lecture so that the flow of the knowledge maintains. In the last chapter, we looked at ML engineering through lens of project work. But that's just one piece of puzzle. Now, I would like to revise few topics from the last lecture so that if you have missed and you don't face difficulty in this lecture, and if you have already watched that lecture, this will be recap for you. So let's see what were the major tenets of a machine learning engineering project. So first was planning. Planning, the focus was alignment between the DS team and business requirements. You should ask what we are building and how it was built before and what do you want to the business team as a DS, that is data scientist. Next is scoping and research. For that, who can test what algorithms has to apply and what literature survey has to be done, that all comes under scoping and research. Then is experimentation. In experimentation, you will have to figure out what algorithms you are using. Are they feasible? Are they reducing the price? Are they complex enough? Are they simple or are they tough for the given project? And what is the feasibility of that? That will come under the experimentation. Next is development. Development will have writing maintainable, testable, and extensible code. Next will be the deployment. In deployment, you will validate the performance such as ML metric, Q&A evaluation, and cost-effective serving. You want your model to be scalable and profitable. For that, you will have to deploy it. It's not enough just to run on Google Colab. So that will come under deployment. Next, you will have evaluation, where you will have model health checks and problem solution validation. These all were the major elements of ML project work. We'll be going in brief of this in the upcoming lectures, but for now, let's go back to the topic and see what is the difference between the data scientist and machine learning engineer. Machine learning is a recipe of technology, people, processes. Technology will have tools, framework, algorithm. So, you might have come across scikit-learn, TensorFlow, PyTorch, Hugging Face while implementing the ML model. These all tools are in technology. You will use some frameworks. That all frameworks will come into technology. So for building any ML model, you need this. Then You will need people. You, as a data scientist, don't have knowledge of everything. So you will need to ask business people for the requirement. You will need to talk with IT department for the computing. So you will have people. So first was technology, then people, and then process. In process, we have software development standards, experimentation rigorously, and agile methodology. So agile methodology, we'll understand that in brief and further, but for now, you can say agile methodology is something which takes iterations, which takes iterative feedback. So if you plan something, then you design, then you develop, then you test, then you deploy and review. In review, if you have few more suggestions, then you will again design, again develop, test, and once it is approved, then only you will launch, so that there is no waste of efforts, there is no waste of time, and there is no waste of money. So agile methodology is very important for software development as well as machine learning projects. Then in this lecture, we'll cover the trio of these all components. If you have seen the previous block, you will see people, data scientist, machine learning engineer, process, agile process for ML, and frameworks, that is DevOps and MLOps, that it comes under technology. So this is how we are going to cover the lecture. This, that is data scientist, is to solve problem. So as a data scientist, what is your job? You are given one problem, and for that problem, you have to give a solution. Now, let us understand few concepts in detail by going one by one. First is augmenting a complex profession with a process to increase project success. Earliest definition of data scientist revolved around three things. That was design of data, then collection of data, and then analysis of data. These all three were considered to be the task of data scientist. So for example, if you want to do some project that is related to, again we'll take a favorite example, cat versus dog. So for that, you will first search for the data set. Here we got a notebook, but you can see first there is a data set taken. We have done the data extraction, and then we have done the data exploration. Then we have divided the data into train and test. With this way, we have divided the data for testing purpose. So we collected the data, and then we are analyzing the data, and then we are running the model and getting the results for them. And then we achieved result that was 97.92. So this way, the task of data scientist was taught that first you should design data, then you should collect data, and then you should analyze data. Modern data science role generally focus on last point, that is analysis of data. And first two are handled by data engineers. Now, let's go to cat versus dog again. You can see here, there is one thing which you can notice, that the data set was already there and it was directly extracted from the Kaggle. So you can say it was directly extracted from the zip. Then it was directly prepared, it was divided for train test, and the main part which was done was using the model configuration that was getting accurate result. So they use VGG16. And as a data scientist, if I have to do this project and get more accuracy, I'll probably try hyperparameter tuning. And for that, I'll change the dropout rate, I'll change VGG16 to ResNet or NASNet. This way, now my focus shifted from design and collection of data. Now, let us see the difference between data scientist and machine learning engineer. First of all, we'll see what all components comes under data science and what are the components that comes in ML engineering and how they are different from each other. We see in the data science, we have feature engineering in which we have data interpolation, we have encoding indexing, we have data interaction, we have vectorization, and we have component analysis. When we come for algorithms, there are a lot many algorithms included in data science. For example, in cat versus dog classification notebook, we see we are using deep learning model, specifically VGG16 model, that is convolutional neural network, as the algorithm that will work for classification. So here we are using CNN. For the language text-based task, we can use recurrent neural networks. And we nowadays use NLP, computer vision, for a lot of language and vision task. In machine learning, then we have supervised learning, unsupervised learning, clustering, time series modeling, and deep learning. As we see in cat versus dog classification, it was a deep learning model. So the machine learning technique used here was deep learning. But at the same time, you can see there are the labels defined. And with respect to that labels, we are classifying the image as cat or dog. And that's why this task will be again claimed as supervised learning because we have labeled dataset. Then we have data analysis. Then we do statistic. We do different kind of visualization. And then we have miscellaneous skill, data manipulation, object-oriented language, functional data interactions. And this lot many things come under data science. So basically, extracting patterns out of data is major goal of data science. Then, along with these skills, we have some other aspects in ML engineering that differentiates the data scientist from machine learning engineer. In that, we have project planning, we have experimentation process, we have scoping, we have agile developments, which we will see in the next part of the lecture, then delivery date commitments. So we have stakeholder contributions, we have communications with subject matter expert, which was not in the data science part. Then we have monitoring and evaluation. So we have predictions, we have analytical dashboards where we monitor our model's performance in real life data and then see how our model is working. And based on that, we evaluate as well. And we have A/B testing as well. I think A/B testing is a little familiar to us as we have seen in last lectures as well, that there are two groups with the audience and they have given two different versions, and we assign the audience randomly and we ask them to evaluate the key performance indicators for that variants, and then they assign whatsoever the scale or rating, and then we compare which one is the best version. Then we have a software development, which is again functional programming based or object oriented based. Then we have model and artifact management. We have model tracking. We have artifact repository. We have logging. So where error comes, so it becomes easy for us to debug. So this all things we'll gonna cover in our lecture series further. But for now, our main goal is to understand the difference between data science and machine learning engineer and how data science is still connected to machine learning engineering. Then we have scalability, where we have training set growth. Then we have ML ETL extract and load. And then we have a deployment, because your model should not be just a Kaggle notebook or Google Colab notebook. You should definitely deploy it in the real world. And for that, we have cost, we have stability, we have language, we have CI/CD pipelines, that is continuous integration, and then we have integration testing. So this all comes under machine learning engineering. But at the same time, you can see this arrow is connected, which says that this all components are equal in the machine learning engineering. You will say, Prathamesh, how this is important if this is all monitoring, planning, and deployment. But you will plan, monitor the model. And for making model, you will need algorithms, you will need feature engineering, you will need machine learning, you will need data analysis. So once you have a model, then only you can perform this all task. And then this task, when they're included, it becomes a machine learning engineering. And if this is just a data part, then it becomes a data scientist. So let's see in brief and in simple language that what is difference between machine learning engineer and data scientist. So specialize in building and deploying machine learning models, whereas data scientist deals with exploratory data analysis, develops algorithms that are optimized for production use, creates a predictive and prescriptive models. As we saw in the previous part, if model is ready, then it is taken to the deployment. So same is explained here. Then integrate machine learning models with existing system and communicates finding through visualization and reports. Then work on model deployment, monitoring and maintenance. And data scientists' major focus will be on extracting insights from data. So this is a brief difference between machine learning engineer and data scientist. But still there is some link between those. So you can't completely assume them as an independent identity. So now let us go to the next part of the lecture. Now let us see how simple approaches in a complex project can help us tackle project in cost efficient manner and in less time. So, before starting, I want to give you a case where you are a machine learning engineer or a data scientist who wants to show that why we received this many complaints from our customer care department and what are the top priority complaints that we should solve. So, what will be the complex approach which you might think? Please let me know in the comments. I want you to think as complex as possible because when I'll contrast you to the simple approach, then you can see that how simple approach can solve this problem easily and you are thinking complex which increase the time and complexity of the resources. So let us see the case where you have to figure out which are the top priority complaints that need to be resolved. So let us see a flowchart for that. You have a customer complaint. Then you will ask the question, is the issue billing related? Yes or no. If it is yes, then it's a billing issue. If it's no, it's a other issue. We can see here, other issue can be again classified. You can ask, is it a payment related issue or transaction incomplete issue? If it is yes, then okay, transaction incomplete issue. If no, then any other issue. In that, you can again see, is it a product damage issue? Yes or no. You can see we have a decision, either this or this, yes or no. In this way, we are going to solve this problem. So you can see there is a decision, either yes or no. So this problem can be solved using decision tree and you don't have to implement transformer, LLMs or complex recommendation system. So this a simple approach can solve your problem effectively. So now let us see the importance of this. Data scientists solve problem by applying mathematics to data creatively without being tied to specific tools or algorithm. Value comes from solving real problems, not trendy technology or latest methods. The best solutions are often simplest that meets the business needs effectively. This approach forms the core of ML engineering because it helps in planning and execution the project in very simple manner. Now, this figure is very important. Let's go through this figure step by step and we'll take a case study and understand how one problem can be claimed as data science problem or we can say that this is not a data science problem. I'd like to first inform you moving down this slope will cause the increase in cost, solution complexity, time, difficulty to maintain, difficulty to modify, and difficulty to explain. So assume the complexity of maintenance, modification, and time increases down the slope along with the cost. So first we have a basic evaluation. It will be asked that it is a data science problem or do we have or can we acquire a data to solve this problem? If answer is no, you should communicate why this is not a data science problem. And if it is yes, then you should think about the simplest way, that is realm of quick wins to solve this problem. Let's take an example of grocery delivery app. They want to reduce the cart abandonment. So we generally check out a lot of items, but when we go to that, we suddenly drop few items or we don't check out and then that is a pending in cart. So we want to reduce this. So first I'll do the basic evaluation. What my basic evaluation question will ask that is this a data science problem? Or do we have a data that if do we have a user clicks? Do we have that what items are added? And what are the items that are checked out and what are the discarded items? If we have this data, then it can be claimed as a data science problem, and then we'll proceed to the next stage. Then when we go to next stage, we'll ask, can this problem be solved with simple data visualization, simple aggregation, simple equation, or a modification to human behavior? So these are very, very basic questions that we ask. Let's take a case study and understand from here. So can this problem be solved when we show a bar chart that these atoms are most dropout atoms? So probably we don't either recommend them or try to show some offer on it. So a simple bar chart or a basic aggregation that which atoms are abound. So we won't recommend those atoms in a group or will simply keep them at the least priority. Then a single equation like cart size and average price. Then can a simple UX change can help us solving this, because sometimes a design can force you a lot, because if the button is very creative or it's very appealing, you may ask yourself that can I click this button, and then you may proceed to check out. This happens really. Change in color in buttons sometimes leads to ordering more things. That's why the design of a project is very important, and that's why UI UX is taken care, because if user experience is enriching, then person goes ahead for more experience. Then if there is a minor change, can we have a simple recommendation, or can we have a reminder? Like if you are about to check out but you found out that, oh, I have to add this item, you went back and then you forgot to check out. That time what we will do is we'll send a simple reminder that, oh, oops, seems like you have not checked out yet. This simple reminder can help us to increase our sale. So this way, if we can implement this, then yes, okay, with the simple approach, I'll solve this problem. So we haven't went to machine learning or deep learning techniques to solve this problem. Then if yes, solve it in that way, move to next problem, monitor the performance of this and tell the stakeholders that problem is solved. If no, if it is no, then you move to the hills of advanced analytics. Then you see, can this solve be a heuristic approach, or can this be solved with rule-based approach, or can it be solved with descriptive analytics approach? If this is yes, then business doesn't care how you solve problem. At some point, as a data scientist, I may think, how am I solving this problem? But business wants this problem to get solved. And for that, until and unless the equation that we are proposing is feasible to them, till that they won't have any problem. So for that, if it is a heuristic or rule based approach and it can solve our problem, then yes, we'll solve that problem and we'll stop at that stage. Let's see with our cart grocery app abandonment example. So a simple rule based system can be added. If the amount is greater than 500 rupees, then the no checkout is done in 5 minutes, then simply we can send a reminder that, oh, please check out as early as possible. Or we can say that if in 2 minutes you check out, you'll get more 10% off. So the simple rule based situations can help you to increase sales. Then a heuristic based a time of a day or user type. So if I see, or if I track some user and I see in morning he usually checkouts, in the evening he doesn't, and I can send him the reminder that, did you forget something to order in the morning? Something like that. So this will help us to reduce the discarded atom, and then with the hills of advanced analytics methods, we can solve this problem. So these methods do not require ML and rely on a domain knowledge or logic. So without a complex or traditional ML things, we can solve a problem. So if as a data scientist, if I receive this problem, you need not to always think about transformer, LLMs, Gen AI agents. You can first think about what simpler approaches can be solved. And this is what we are gonna learn through this entire machine learning series, that this thinking is equally important with your technical skills, because after all, business stakeholder needs something that is feasible and cost effective for them, and that solves their problem as well. So now let's see if a traditional ML is still required. If the problem is still not solved with the heuristic or rule based approach, then we'll ask, can the classic predictive modeling, that is regression, classification, clustering, solve the problem? Then we'll ask prescriptive modeling, that recommendation engines or simulation can solve. If yes, again, business doesn't care how you solve problem until and unless that is feasible, technically aligned with the requirements. That's why if it is solving this, then again, don't go for LLMs or transformer because they are trendy. Go for the simple approach where traditional ML models are still very effective. And let's see the case study and let's understand. So, logistic regression or random forest to predict the likelihood of abandonment. So, we have seen this example of customer complaint classification. Like this, we can have a decision tree to decide and to predict whether this will be discarded or not. Similarly, now, if still none of this approach works, and then we'll go to our favorite advanced deep learning techniques that are peak of complex AI. So, if still the problem is not solved with traditional machine learning, we'll go for deep learning techniques, graph based modeling, or classic complex predictive modeling. So, if that problem can be solved, yes, then again, business doesn't care how you solve the problem until and unless it's feasible and cost effective for them. And if still you can't solve that problem, then it's no. That probably it is not a data scientist problem. So you need to tell your company that this is not a data science problem because company probably won't allow you to develop any algorithm from scratch because that will be a time ineffective strategy. But if it is not a data science problem, then you should convey them with your proper justifications. And this is what is very important to learn. Not every problem that is assigned to you will be a data science problem. If some problem is assigned to you, first you should analyze that whether it is a data science problem or not. And then only you can proceed ahead. These things are often overlooked by us and we directly go for model building, which is not appropriate. Now let us see that how complex AI can solve our grocery delivery app problem. So if we have a deep learning methods, then a session-based clickstream data might help. Graph-based models help us to understand co-purchase behavior. We can find what pair of items are checked out together. If someone is buying Surf Excel, then brush is also buy. So if someone doesn't add brush into their cart, we can give a simple reminder so that our sales increase and then probably they check out. So this way we can add this. Then this approaches should only be considered if simpler methods have failed. Because I am again telling business is most likely a very important thing in any of the problem. So if that is successful, feasible, then only the solution will be accepted. So please apply this problem techniques once you have thought of this earlier stages. And if none of them works, then only consider applying this complex technique. You can see, as I said before, the slope along this down the slope, the complexity increase, cost increase, and complexity to modify to maintain increase. And that's why this approach should be considered only if the simpler methods have failed and the business case is strong. Then, if this doesn't work, then you need to reevaluate and discuss with the stakeholders. And if problem involves developing new AI algorithms, then it may not be feasible project with respect to the business. And then probably you should convey them that this is not a data science problem. So this stepwise approach emphasizes starting and simple approach and then increase the complexity if the problem is not solved and deliver the most simplest approach for the given business problem. Now, since we have discussed in the earlier part of lecture that we'll discuss about the agile principles in software engineering, and then we'll discuss about how agile can be aligned to your machine learning engineering. So what is meant by agile? Agile process in software development generally deals with the iterative and incremental development. It collaborates with customer and is a flexible model where a customer and client can give you feedback and upon that you can reply. and you can improve your model, and with that reply you will again get feedback, and again you can improve your work. So that is continuous improvement and flexibility. Author Ben Wilson in his book has related agile principles in software development with a machine learning engineering. It is strange that how software project management principles can be used in machine learning engineering. And we have bunch of agile manifestos, basically around 12, which are aligned with machine learning engineering. And comparing this might be little tough. So we'll take some case studies. And with those case studies, we'll try to understand how Agile Manifesto can be used in machine learning engineering. Then we'll focus on two major agile principles. That is communication, and then we'll also see about embracing and expecting change. Agile principles are followed by all the companies in the machine learning domain. So let it be Amazon, let it be Walmart, or let it be Uber. This all follows the Agile methodology. So for Amazon, the recommender system follows the Agile methodology. For Amazon, recommendation system follows Agile methodology. So they introduce recommendation model incrementally through A/B testing. I think by now you have a little knowledge about A/B testing. Then use clickstream data to validate model impact on KPIs like sales and session duration. Then Mayo Clinic, that is, they develop ML models for predicting the patient risk using doctor in loop. So they take a human, so you can see a client is taken and the model is presented before the client, and then feedback is taken at every step. So this is how the ML works and with respect to Agile. So in the case of Mayo Clinic, they develop ML models for a patient risk classification with doctors in loop. They adjust data pipelines and model explanation based on clinical feedback. So a client brings you a problem, you develop a model, and then clients give a feedback, and then you iterate it and improve it. This is what is Mayo Clinic is doing. Then Uber. I have seen many times the sudden increase in fare. I was booking for 50 rupees, and then if suddenly the time pass 5 and it's a traffic time, then the cost increases and it goes to 100. How is this happening? So for that, they even had the collaboration with operations team where they refine models based on real world fairness and feedback. They first deployed their model on small regions, tested it locally, and then they implemented as a full-fledged model. So first they tested it on small portion, and upon getting a good results, they extended it. Then Duolingo. Duolingo always forces you to maintain a streak, and that is a simpler interpretable model. They use A/B testing. So you are trying to maintain a streak. In that way, you are interacting with the app daily. This is how your users of app increases. Then Walmart. Walmart is inventory demand forecasting. So it is a time series model across selected locations. So that is deployed incrementally to reduce operational risk. This is how the agile principles are used in real life. And in the cases, if the most of the companies don't rely on agile methodology in this era, probably they won't sustain much and you won't get a real-time prediction as correct. Every agile principle is important in ML pipeline. But now let us consider two, and then we can proceed ahead. Now let us focus on two principles which are very important. First is communication and cooperation. Collaboration is very vital in ML than traditional Agile because the work is complex and sometimes it's difficult for non-technical teams to understand the mathematics, deep mathematics behind your model. So you need to collaborate so that you are on the same page. Then you can have a regular, clear discussion between ML team and a business units to avoid misunderstanding and reduce costly work. Next is strong communication. Strong communication within the ML team itself is the second key to the project success. If you just think this is a school and you just start working on project and you say I'll finish the project, I'll take the advantage that I'm the first one to finish this. This is not the case. This is a teamwork. For that, you need to communicate with other teams because nobody is master of all. You need to have just enough knowledge, but at some point, everyone has some expertise. When this all expertise come together, then only you can make a successful project. Then working solo may work in school, but not in real ML projects. Teamwork is essential for solving complex problems effectively. Let us consider two scenarios. First is risky behavior. What you did is you gather the requirements from a team. Say you want to make an app, calculator app. So you said, okay, you want to build a calculator. It should perform a basic calculations. This is what you think. Then you build a complete solution. You build a calculator app and you demo the customer, the client which asks you to develop a calculator. Does it meet needs? So it's a very rare chance, and even author Ben Wilson says that he have never seen this happen on the first try. If it is yes, then the production code will be there. But if it's no, then sorry. You have to work again and you have to rethink about your approach. The entire process is repeated again. What if they want a scientific calculator or they want a currency exchange in that case you didn't thought when you were dealing with the requirements gathering. So you were not confident enough, but you assume you take a risk and develop a solution, which was waste of time and waste of effort. But at the same case, if it is an agile aligned methodology, then you gather the requirements. You have a research option. You research what kind of calculators are already available in market and what options I can implement. Can I implement a currency exchange? Can I implement the scientific calculator? Can I implement a normal calculator or all three? Then you discuss these options with customer. Then you build a feature. Then you show demo. If that demo is okay, then the code goes for the production if it meets need. But if demo is not okay, you analyze the failures and then you again go for the research options and think how I can improve. But here you may thought that okay, Prathamesh, we are showing the prototype after all. But that take a difference, I say a prototype. We are not showing the exact final app. We are showing demo. We are not showing the app. So this is a difference between the agile aligned methodology and risky behavior methodology. Now, hope this agile aligned methodology showed you how this iterative feedback mechanism will help you to solve the project more efficiently without wasting time. So engaging more with your team leads to better ideas and stronger solutions. If you leave out your peers or business stakeholders, even in small decision, there is a high chance that final outcome won't match their needs or expectation. Let us have a look on the embracing and expecting change. Change is inevitable in ML project as at start, the client wanted a simple calculator. He just want a normal calculator app. And I just searched for the normal basic UI, got this. I thought I'll recreate similar to this. And I just made the app accordingly and show the final app or prototype to him. He was not happy. Why? Because he thought that many people use scientific calculator and currency exchange, which is missing. How can I add it? But he didn't got it. But he didn't get it when he was approaching us for the first time. And that is very obvious. When you proceed further in project, after that time only you will be able to think that what can be added more. And you must be ready as a data scientist or machine learning engineer to incorporate the changes. Expecting the changes make you focus more on the goal, because you'll have in the back of mind, okay, this can be added at any point of the timeline and I should be prepared for this. Planning for change means designing modular, flexible system. Agile methodology fits well with the ML work. It's an iterative approach that supports building adaptable and evolving solutions. Thinking ahead saves effort. Without this mindset, even small change may require complete rewrites. If after publishing your research paper, if you think some things need to be added, then you'll have to work again on it. But still, if you release the preprint versions and you keep that updated, then it will be very easy for you to publish the final draft. So you have some initial ML system, then you get a new business requirements, then you apply a new algorithm, then you have a data assumption and you try to solve the problem. The problem was solved using ML or a non-ML approach after the addition of the new data or new requirements. So this is how the embracing change helps you to deal with the project complexity in a well-defined manner. Now, DevOps is clearly related to the development, and the terms here are little complex. As mentioned earlier, we'll go through all these terms one by one, so no need to worry about it. So it has agile methodology, it has software engineering standards, it has packaging, it has monitoring, it has the release, it has CI/CD, that is continuous integration and continuous deployment. Then we have a code review practices, that is peer review or unit test coverage. So you can see it revolves around a monitoring, deployment, evaluation along with the concepts of agile methodology. This is DevOps. Now let us move to MLOps, that is ML plus DevOps, MLOps. So what changed? First, let us think about agile methodology. What we saw, agile methodology first was used in software project management, but now it can be aligned to ML as well. So we have ML agile methodology. This is different from the DevOps. Then in monitoring, we have logging, we have fallback or failure rate, because the prediction of a machine learning model might be in some evaluation metrics. For now, consider accuracy. Then you have release. In release, you have a A/B testing evaluation. As we have discussed before, which version is better in terms of key performance indicators needs to be launched. So for that, we do A/B testing, which is not done in the DevOps. Then we have CI/CD, that is common in both, that is build tools, continuous integration and continuous deployment. Then we have code development practices. Then we have code review practices. In that we add a metrics validation, because you need to validate the accuracy, F1 score, precision recall, false negative rate, false positive rate. Then you have an environment configuration. In that you have a development, you have QA, you have production. And then we have an artifact management, which is not separately here in DevOps. but you have it in the MLOps, where you have the artifact repositories, registrations, Q&A simulation test. We'll go through all these concepts in detail in the lecture series, but just for now understand this is the machine learning in the DevOps, and here all the machine learning evaluation aspect, monitoring aspects, agile methodologies will be added, and then only we can call this as MLOps. Look at this diagram. You can see ML is integrated in development and operations. For that, you have a model and you have a data. When ML comes, you always have one model and data for that. So always think that everything related to this data and model in respect of evaluation, deployment will be added in the MLOps. And that's what we saw in the figure as well. That there is a metrics validation, then you have A/B testing, then you have ML agile methodology. This is all. So just have a recap of what we have learned till now. We have saw data scientist deals with the data and tries to analyze and let's have a quick recap of what we have learned. Let's see data scientist and machine learning engineer again. Machine learning engineer deals with deployment, development, and data scientist extracts the pattern from the data. Then we saw how a simple approach can solve project more efficiently. Down the slope, the cost and complexity increases, but not always ML problem has to be solved with a ML concept. Sometimes it may be the case it can be solved with a heuristic or rule-based approach. Then we saw the Agile manifesto in machine learning engineering. And then we ended up with DevOps and MLOps, differences and similarities. And in the upcoming lectures, we'll understand these components, terms in detail with the real-life examples. Next lecture would focus on planning and scoping, and we will try to divide that lecture into two parts so that you will understand how important planning is. And as we are moving ahead, we'll go more into technical stuff. So please stay tuned and be patient and make sure you follow the lecture series. At some point, if you're feeling this is getting monotonous with the theory, remember that this knowledge is equally important with your ML technical knowledge, and you have templates that you will be consistent throughout the course. And let me know if you have any feedback and suggestions for us. And if you want some specific topics to be covered in future, please comment down so that we can try to take them at priority. Thank you. See you.